In a previous video, I showed all 48 pencils for Prismacolor for alignment as an analysis. I'm making this other version, a slow version, in which I'm only including the extremes. I'm only including the 5 pencils that are the most well aligned, the 5 that are least aligned, and then the typical one of the typical ones. Because in this particular version, I want to go slowly through the grids. Um, So I'm going to repeat what I've said in the previous video because in some cases, some people will only watch this particular video. So the setup is I took 2 rolls of duct tape. I put them on my stamp scanner and I used a sheet of acetate to make sure that the any of the pigment from the coloring pencils will not affect the glass because I want to continue using the scanner for stamps. So then I put in all these pencils in addition to the 48 Prismacolors to make sure they stood real tight and straight up. And so I was able to do that by adding 34 pencils, 34 graphite pencils, which means that if you took 2 rolls of duct tape as I did, you can probably do this for a 72 set. I'm not sure that I will. So here's the scan from which I based all the images. It's a 2400 dots per inch scan. It's an 80 megabyte image. Clips to 60 megabyte when you take out everything else. Of course, I kept all the scans to highest resolution, and the pencils are number 1 to 48, and they're not matched to the Prismacolor number. I came up with a grid. It's rather crude. It's from Google Sheets. It's just a way to get close to an assessment, but because of the way these grids move within Google Sheets, I don't land exactly where I want to land. So, um, so then when I go back here, there's 44 DPI, 2400 DPI images for the 48 pencils, each 1 megabyte. There is a link. I've placed it in the video with the 48 images. I'm going to place it also here to a Google Images file folder that has all the images if you want to download them or look at them. And I only have 1 pencil that I couldn't get a good scan of, and incredibly enough, it was pencil number 1. What a coincidence. So anyways, the images are of higher resolution, so you can actually zoom in. If you download them a little more, they're a little bigger than what fits in these slides, which is great. 2400 DPI is the way to go for this type of work, in my opinion. So let's get to the misalignment. So the errors, of course, the images are not the exact same size. I should have clipped them to the size of the barrel and actually even rotated them to the slat to be horizontal or vertical, but be always in the same way so you can look at the wood in a more representative fashion. But for this analysis, the first time I've done it, it's fine for now. So yeah, here's pencil number 1. It's really blurry in the background. It's off by 0.5 units to the right. The units are arbitrary, so it's a grid of, roughly 5 to the right, 5 to the left, 5 up, 5 down. I think these pencils are like 8 millimeters in diameter. So I think each one of these squares is a little less than a millimeter by a millimeter, maybe like 0.6, something like that, 0.6 millimeters. And then, of course, when I detect the misalignment X and Y, I use good old high school geometry to come up with the actual distance of the total misalignment. So the most aligned pencil is pencil 10. These are the 5 most aligned. And you can see right here that my analysis technique is very crude because actually this pencil is not perfectly aligned at all. It's got a little bit of a misalignment, but the misalignment is so small that in my way with the errors that I have, it's really as good as perfect, basically. And so when I show it again in the way that I would have it in the regular slides with all the other images, you can see right here that if you start counting, let's just take the x-axis, the horizontal axis, you see that it's got like 3.5 grid squares to the right, and you can see on the left it's like 3.6. Yeah, something like that. And then if you go up, it's really got about 3.6 also, And if you go down, it's got about 3.6. So it's pretty close. I would say it's slightly to the left, but pretty close. Pretty close. Then the other really well aligned ones, and I don't know what what landed on the glass that's not part of the pencil. Could have been something loose that was on the glass from before. But pencil 3 is nearly perfectly aligned. And when you look at pencil 3 with the grid, you see right here that if you go to the right, it's like 3.2. If you go to the left, it's about 3.4, something like that. So it's really off to the left. But when you look at the north and the up and down, they're really like 3.3 both ways. It's really hard to get beyond 0.2. I think I couldn't measure it to 0.1. So I think the error in these measurements is about 0.1. Then pencil 9, and I'll just show the image here because I'm actually trying to go slower in this one. I was watching the longer video with all the scans, and I went so fast. I think I may eventually even delete that video. And this one's the one where I think people are going to be able to see the grid slowly. So here you have pencil 9. It's well aligned. If you count on the x-axis to the right, you're going to see like 3.3. If you go to the left, I think it's like 3.7, something like that. I did this a little too quick. It's actually a little more than 0.2 to the left, but it's pretty well aligned along the up and down. If you look at up and down, it lands in about the same place. And again, there's a second analysis that can be done that's better than this one. This is the very first time that I've done this, so I think I'm even noticing that some of my measurements are not exactly that great. 14 also pretty well aligned. So when you look at the grid, the x-axis is about 0.2 to the right, but when you look at the up and down, it's really close to exactly right. Again, with some error, but you know, it's pretty good. And then 29 also seems to be well aligned. So when we put the grid on it, you see that to the right it's like 3.4, to the left it's like 3.6. So yeah, it's 0.2 to the left. And then when you look at the up and down, it's about 3.3 each way. 3.3 in the up and in the down. So, and then in the case of the least aligned, poor pencil 16 won the contest. I'm not. I think this is either flesh. I think this is flesh. So it's off to the right by a lot. I'm counting like 4.6 to the right and like 2.6 to the left. I think I should have said 2 instead of 2.2. I was a little off, I think, in my measurement. But then when you go up, it also is up by 0.6. If you look at where the grid intersects the center line in the up and down. So yeah, it's really way off, and noticeably so. And pencil 5 is also way off. If you look here, you'll see that it's pretty far to the right and pretty far up. So like 4, it lands on like 4, and on the bottom it lands on like 2.3. So yeah, like 1.7 up. And then to the right, it lands, I would have said like 3.7, something like that. And then on the left is like, yeah, I'd have to do these measurements again, but it's a lot. It's a lot. I think there's room for me to do these analyses better than this very first time. But here for the pencil 31, you can see that it's really way off to the left and up. So it's way up. And then pencil 39, and this is what I think I need to do in the future for these. If I ever do this again, to go a little slower, so I can show. And actually, I can see a very small hair. Is it a hair, or is it lower right? I see something. Anyways, so yeah, this one's to the right. Definitely a lot to the right in misalignment. And then pencil 15, I can see it's a little north. So sure enough, it's about 1.1 units up, and it's about 0.8 units to the right. And there's a better way to do this grid. I mean, this is just the first time that I've done it. Yeah, there is a better way. So the summary, of course, same as the shorter, the longer with all the slide, with all the pictures. This slower version. The average alignment is 0.88, which is poor. And yeah, I can do a lot. I can do a lot better, as you can tell from me narrating this this video right now. So yeah, pencil 18 is your average Prismacolor pencil from this selection of 48 pencils, and it's off about a total units, whatever that unit means. So I guess it would be 0.5 to 0.6 millimeters.